Okay, the last one, for a given function x squared minus 9 over x plus 3, suppose we want to find first at what number will this function be discontinuous. So discontinuous at what value or values. So this time, the problem is not telling you where, but you have to identify it on your own. Possible point or possible value of discontinuity. Usually, kung saan siya undefined. So x equals negative 3. So we will be checking the continuity at x equals negative 3. Well, actually, because it's a rational function, just by considering the domain, we already know it's discontinuous at x equals negative 3. Okay, the question is, later on, what type of discontinuity? So we will still be working with the 3 steps. Okay, so step number 1, f of negative 3 is undefined, tama? We have, let's see, x squared minus 9 over x plus 3. By substitution, 9 minus 9 over negative 3 plus 3 is 0 over 0. Okay, so here, do not be confused with 0 over 0 for this and the 0 over 0 of the limit. Okay, pag ganyan na yan, 0 over 0, wala nang value yan. Okay, undefined na yan kaagad, okay, from the domain. But if we work on that for limits, so part 1 failed already. It's already discontinuous. But number 2 will tell us what type of discontinuity. So we check what is the limit as x approaches negative 3 of x squared minus 9 over x plus 3. Okay? So direct substitution will give us, again, 0 over 0. That indicates that we need to do something with the expression so that we could find the limit. And from the limit exercises earlier, anong ginagawa? Factor x minus 3 and x plus 3 over x plus 3. So the limit exists and it is equal to negative 6. Okay? Even if you check it from the left side and the other right side, you will get the same negative 6. Okay? Because we were able to directly get the limit even just by using the substitution. Okay. So part 2 work. So it's discontinuous. If the limit will exist, then we expect a whole. Okay, it's not even an asymptote. Okay, kasi the limit will exist. Ibig sabihin, magmi-meet sila supposedly. Okay, but the function is undefined on that number, so it's a whole. So this is what type of discontinuity? And we say this is a removable, hindi na siya essential, removable discontinuity. Okay. Now, how do we, so we already answered what type of discontinuity. It's a removable discontinuity. Sometimes, you will be asked to redefine. How do we redefine the function? If that is the task, what you need to do is to create a piecewise function. So consider the original x squared minus 9 over x plus 3. Okay, when you redefine, remember the limit value that we obtained? negative 6, you place that on the new function, okay? But you take note, the first expression x with minus 9 and x plus 3 will work with all the numbers except for negative 3, because it is undefined at negative 3. But redefining it with x equals negative 6, you introduce negative 6 for x equals negative 3. That's how you redefine. You just add, okay, the limit value, negative 6, at that number x equals negative 3. So when you do that, in terms of the graph, remember there's a hole. So that negative 6 at x equals 3 will fill the gap. Okay. So now remove. Okay. That is why it is called removable discontinuity. We were able to remove the discontinuity because we redefine the function. Okay. Originally, it's still discontinuous. Okay, but the redefined function is now continuous. Okay, clear?